All right, so this is the mid-chapter quiz solutions. So this thing z varies jointly with x and y. That means both jointly means directly, but there's two of them. So both x and y go on top, and when it varies, remember it varies by coefficient or constant variation k. I substitute the values of z, substitute the values of x and y. I highlighted them here. Plug them in. You solve for k. Then you just go back and plug the k in, and that's the answer. All right, the next one, it varies directly with x, so x goes on top, but it varies inversely with y, so y goes on the bottom. X is on top directly, y goes on the bottom because it's inversely. Substitute the values, solve for the k. 30, I can cancel out the 3 by dividing by 3, but I multiply by 2. I just did multiply by 2/3 to make it quicker. So k is 20, and then you just rewrite the equation with a k, with a 20 instead of the k. All right, number 3, it varies inversely with the product of x and y. That means x and y are hanging out together, but they're both inversely, right? Because of the product, they're multiplied together. Again, substitute the values, multiply by 6 on both sides, solve for k. You get k equals 180, and so you just plug that into the original equation. Instead of having k, you have the number 180. That's it. All right, those are easy. Now, let's look at these. We want to see if it's direct, inverse, or neither. Now, since both are going up, see how I have little pluses? Is it direct? Maybe. And there's a good chance it's direct because they're both going up. So we're just going to see if they have like kind of the same scale factor, the same constant of variation, or the same constant of proportionality. You can set this proportion up a lot of different ways. I divided the x's by other x's. Really, it would have been just as effective to divide each y by each other x. So I'm going to do that here. I'm going to divide the first y by the first x, the second y by the second x, the third y by the third x. Now, technically, you get different numbers. But in real life, I would say these are a direct variation, but maybe like by math test standards, it's not exactly direct. So I would say almost direct here, but technically neither. Okay. For the next one, notice how the first column, the x's go up, they increase, while the y's go down, they decrease. So maybe this is inverse. There's a good chance it's inverse because if it's direct, they both go up and up. If it's inverse, one goes up when something else goes down. So let me just plug in the values. That the regular inverse equation is y equals k over x, or x equals k over y. It doesn't matter. Let's see if we get the same proportion of constant of proportionality, that same k. So I just plug in the first x and y points. I solve for k, and then I just put that into my calculator. And this value of k, well, let's see if it happens that way when I do the second set of points. If I do the second set of points, and it gives me that same value of k, then that means that this would be an inverse relationship, but I get a different k, so that means that it's neither. Okay, next one. One goes up while the other goes down, so maybe it's inverse. Maybe it's inverse. So again, I do set it up the same way, y equals k over x. Plug in the first point, the first y into y, the first x value into x. And so the 2.4 equals k over 15. I get a constant of proportionality, which is the k. I get a k value here. And then let me put the second value and see if I get the same thing. So the first one I got a 36. Let me plug in the next values. Hey, look, I got another 36. Now, if it worked for 2 points, you can pretty much settle it right there. It's just going to keep working. But just to be sure, I'm doing it with the other points. Just to be sure. I'm plugging it with the next set of points. Notice I'm plugging y for y and x for x. And then, boom, you keep getting k equals 36. You'll get that all the way down if you check all of these. Okay? But this is going to definitely be an inverse relation. One goes up while the other goes down, but they do it at a constant rate. All right, next one. We want to do an inverse function. Again, y equals k over x. Even though I can actually write this a different way. I can do x equals k over y. I just choose to do it this way. But solve for the k. If you solve for the k, boom, you get your answer by multiplying it. So rewrite the equation, y equals 221 over x. Number 8. Again, y equals k over x. The key word is inversely on 7, 8, 9. It all says inversely. So that's why we put the x on the bottom. Again, just plug in the numbers, solve for the k, and we get y equals negative 48 over x, or negative 48 divided by x, if you want to say that. I just say over. Again, inversely, number 9. So They give us an x and a y coordinate, and they want us to solve for the constant k that makes this stuff work. And so here I did it by 1/4 equals k over negative 52. You mostly multiply negative 52 times 1/4, I get negative 13. But like I told you, there's a different way to do it. Instead of doing y equals k over x, I'm going to do x equals k over y. Well, guess what? It actually doesn't matter because you end up multiplying those two numbers by each other anyway. Multiplication is commutative. So instead of 1/4 times negative 52, it's negative 52 times 1/4. And oh, wow, I get negative 13. Surprise. So with direct variation, with inverse variation, doesn't matter if you do x equals k over y or y equals k over x. These are actually the same equation. You can graph both of those in Desmos. Promise you they'll be the same. All right, number 10. We just want to say, how do you get from one to another? All right, the 4 and the 9. Well, obviously, 9 is bigger than 4. So that means that the one with the 9 is going to have a more of a vertical stretch than the one with the 4. Now, I'm going to show you just by how you get from one to another. Let me write the first one, 4 over x. The second one is 9 over x. Notice how if you multiply the first one by 9/4, you get 9 over x. So there's y1, there's y2. So it's a vertical stretch of a factor of 9/4. So it's like the first one, y1, is being multiplied by 9/4 to get the second one. Let me show you the graph just so you can really internalize that. Notice how 4 over x is, it's out there, but 9 over x is more out there. It's like it's just more up, but it's also more down. It's literally stretched in the vertical direction. So yeah, it's stretched above, but it's also stretched below too. It literally is just, that's why we call it a vertical stretch. Okay. So yeah, you can say taller. 9 is bigger than 4. You can see it that way, but vertical stretch is the correct way to say that. This one right here, notice how the only difference is the +5. You should know this, just like what we did with other kinds of equations. It's literally just adding 5 to the y value. So it's a vertical shift of 5 up. If it was a -5, it would be a shift down, but it's a +5, so it's a shift up. So it literally just moves that function up by 5 units. That's all it does. So we can say it a lot of different ways. Just to prove it to you so you can kind of internalize that. Like, wait, how can I confirm this? Well, look at the green one. That's the original. Look at the orange one. That's the after the shift. And notice how it shifts up by 5. And just so you can be sure, I'm going to go to this random value at 10. Notice how it's at 10. The first function is 10, 0.1. The other one's 10, 5.1. They're literally a difference of 5. All right, that is it for the first part of this.